Have you ever wondered how the sun, the very heart of our solar system, came into existence and what will become of it billions of years from now? This fiery sphere, the center of our existence, is far more than just a glowing dot in the sky. It's a celestial powerhouse, a giant nuclear reactor that fuels life on Earth. The sun's life cycle, from its spectacular birth to its inevitable death, is a topic of fascination and curiosity. It's a journey that spans billions of years and has profound effects on the universe. Its existence shapes the orbits of planets, influences the formation of other stars, and even impacts the potential for life on distant worlds. Yet, despite its importance, the life cycle of the sun remains somewhat of a cosmic enigma. We have many theories, some answers, but also countless questions. Join us as we journey through time and space to unravel the life story of our most vital celestial body, the sun. Our story starts around 4.6 billion years ago in a cloud of gas and dust known as a nebula. This nebula was far from idle. Instead, it was a cosmic whirl of activity, teeming with gas and dust particles. Over time, these particles started to interact, their gravitational forces pulling them together. This gravitational pull caused the nebula to collapse onto itself, forming a dense, hot core. This core, or protostar, was the sun in its infancy. As the protostar continued to contract, it grew hotter and denser. The pressure at its core increased until it was so intense that hydrogen atoms began to fuse together, releasing an immense amount of energy. This energy pushed outward, counteracting the inward pull of gravity, and a delicate balance was struck. This process, known as nuclear fusion, marked the birth of our sun as we know it, and hence the sun, our beloved star, was born. For about 5 billion years now, the sun has been in a phase called the main sequence. This period in a star's life, including our sun, is marked by a delicate balance of forces. The gravitational pull tries to squeeze the sun, while the pressure from nuclear fusion reactions in the core pushes outwards. This balance, or hydrostatic equilibrium, keeps our sun stable. In the heart of the sun, a thermonuclear process is underway. Every second, about 600 million tons of hydrogen are converted into helium. This process, known as nuclear fusion, releases an enormous amount of energy in the form of light and heat. It's this energy that lights up our days and supports life on our planet. This process of burning hydrogen into helium will continue for approximately another 5 billion years. But remember, while the sun's main sequence is long, it's not eternal. But nothing lasts forever, not even the sun's time in the main sequence. In about 5 billion years, the sun will exhaust its hydrogen fuel and start to change dramatically. This transformation will mark the beginning of the end for our star, and the signs will be impossible to ignore. First, the sun will expand into a red giant, engulfing the inner planets, including Earth. Then it will shed its outer layers, creating a planetary nebula. What remains will be the core of the sun, compressed into a white dwarf. This white dwarf will be about the size of Earth, but with a mass comparable to the sun. Despite its diminished size, the white dwarf will continue to shine for billions of years, gradually cooling and dimming until it fades into a black dwarf. But that's far into the future. The sun's transformation will drastically alter the solar system. Planets will be scorched, orbits will be disrupted, and the night sky will look vastly different. In its death throes, the sun will have a profound impact on our solar system. Our sun's journey from a nebula to a white dwarf is a testament to the dynamic nature of the universe. Born in a stellar nursery, our sun was once just a cloud of gas and dust. Over millions of years, it transformed into a spinning, glowing ball of gas, entering the main sequence phase. This is the sun's longest life stage, where it has spent and will spend billions of years fusing hydrogen into helium, shining brightly and providing life-giving energy to our planet. Eventually, though, the sun will exhaust its hydrogen fuel, ballooning into a red giant before shedding its outer layers and shrinking into a white dwarf. But even in its death, the sun leaves a legacy. Its released gases become part of the interstellar medium, potentially seeding future stars. Its gravitational influence continues to shape the solar system. And so, the life cycle of the sun is a cosmic tale of birth, life, death, and legacy.